Oh, now we have sound. That would help. This idea of U substitution comes from undoing the process of the chain rule. So remember, our chain rule is outside derivative of the inside function times derivative of the inside part. And what we're going to start to do today is to start to figure out on our own what U is going to be. And remember, the pattern is that we have two big clues to tell us what U is going to be. The biggest clue, clue number one, is that you have a function that's inside of another function. So up here we had the 2x happening inside of my secant and tangent. I had the 3x happening inside of sine. And that's your that's one thing of the chain rule, is it tells you the derivative of a function inside another function. And then the second part is spotting that times the derivative of the inside part that is a part of the chain rule. And so if you see the derivative of a function somewhere else in the function, then that can help you see that we're going to have that chain rule happening. So for example, on this one, we're giving you U, but here's how you can spot it. Thank you. Big clue number one, it's being squared, so it's inside of another function. Big clue number two, what is du? What is the derivative of this? Well, derivative of 1 is 0. And then derivative of negative cosine is going to be a positive sine. Because derivative of cosine is negative sine. And so this derivative is going to be a positive sine of t over 2 times derivative of the inside part, derivative of t over 2, is 1/2, because it's 1/2 t. dx. And so du equals 1/2 sine of t over 2 dx. And now I should be able to exactly replace. Well, hold on, there's a problem. Because I can't exactly replace this because there's this 1/2 that's not in the problem. So we're going to move it to the other side so I know what exactly to replace sine of t over 2 dt with. And let's use dt instead of dx because there's not an x in the problem. That's my fault. So we're going to multiply by 2 on both sides. So 2 du equals sine of t over 2 dt. There we go. So now, here's where the process gets easier. Because instead of 1 minus cosine of t over 2 that we're squaring, instead, we are just squaring u. Much easier to deal with the antiderivative of. And instead of sine of t over 2 dt, what is that going to be equal to? Well, that matches exactly with 2 du. So instead of all of this stuff with the sine and the t over 2 inside of the sine, now we just have 2 du. And as we talked about on Friday, if I have a constant multiplied here, then I can take the 2 and bring it out in front. And now we just have u squared du. So antiderivative of u squared will just be 1/3 u cubed. And now, we can put back in our u that we substituted. What was u? We had 1/3 u cubed. Well, u is, let's see, 2 times 1/3 is 2/3. And what was u? What is the thing that we're cubing? It is the 1 minus cosine of t over 2. That's what we're cubing. Plus c. So this is what u was going back in. And so the goal, to kind of zoom out, the overall goal, once again, is that we don't have to think as much about the chain rule within our antiderivative. When we're taking the antiderivative, all that we have to worry about is the derivative of u squared. And we're thinking about our sine of t over 2 and the derivative of the inside part and all of that before and after we take the antiderivative. So it simplifies that process of taking the antiderivative. And again, we do this little tweaking of multiplying here because that will make it match exactly with what's in the actual integral. If there were 1/2 here as well, then we wouldn't have to do the multiplying because we could just substitute it for du. But we don't want to know what 1/2 sine of t over 2 dt is. We want to know what sine of t over 2 dt is. So we're going to make it match this. And we do that by the multiplying by 2. Manipulate it like that to be what?
Like to make it match with the function. Like moving the 2 over.
Usually, so the question was about making it match like that. Usually what's going to happen is that the process will make it so that this kind of derivative of the inside part thing is going to match except for some constant. And so in this case up here, du was 2 dx. Well, we don't have 2 dx here, we just have dx. And so we divided by 2 to make it match. So usually all that is required is for us to multiply by the constant and then it matches. Okay, let me come back to part C because it's more challenging. Let's do some more problems where we have to figure out what u is. Let's start over here with part D. Once again, part C is harder and we'll come back to it. Might not look as hard, but it is actually trickier than it looks. Now, some of you might be able to do part D without a u substitution at all, and just thinking about the chain rule and how it undoes itself. But let's take a look at how this process of a u substitution would work. And usually, the big hint for what to make u is going to be in big hint number 1, which is we have a function happening inside of another function. And so in this antiderivative, what function is happening inside of another function? Which one's my outermost and which one is my innermost? So the outermost here is cosine. And the innermost, what's happening inside the cosine, is the 3z plus 4. So that's what we're going to make u. That's what we're going to make u because 3z plus 4 is inside the cosine. And if I'm thinking ahead here, what's going to end up happening is that instead of cosine of 3z plus 4, we're instead thinking about cosine of u. That's our goal. Now we need to figure out what du is going to be. Du equals derivative of 3z is just 3, and then derivative of 4 is 0. So 3 dz. But I don't want to substitute for 3 dz, I just want to substitute for dz. So I'm just going to divide by 3 on both sides to make it match what's in the original problem. So 1/3 du equals dz. So let's do those substitutions here. Integral of the cosine of, instead of 3z plus 4, we just have u. And instead of dz, what does dz match up with? Well, it matches up with 1/3 du. So once again, we have this constant that we're multiplying, so I'm going to bring it out in front so that I don't have to think about what's going to happen with the 1/3 until the end of the problem. The goal is to make the antiderivative part as easy as possible. So we're bringing constants out in front. We're taking functions inside of other functions and not worrying about them when we do the antiderivative. That's the whole point of this substitution. So, antiderivative of cosine should be positive sine, because derivative of sine will be cosine. And now that we've done the antiderivative, now we can do our substitution back in. So it'll be 1/3 times the sine of u. What was u? It was 3z plus 4. Plus c. Questions on that? All right. I want you to think forward to part E and part F. We're going to end with doing those two. And I want you to think about and try and get as far into those problems as possible. But what I want you to get an idea of at least is, what are we going to make u? In this problem. I think spotting in an F is easier than spotting in an E. But E is also the first problem, so maybe you spot it there first. Remember the two big clues that you're looking for. The function that you make u should be happening inside of the other function. And then a bonus if its derivative is somewhere else in the function. In other words, will du be substituted for something that is somewhere else in the problem? And it's okay if you try something for u and it doesn't work at first. And you got to try it again. We're just starting to put together the pieces and testing things out for different problems. So what I'm seeing so far, at least from this half of the room, is that we're getting pretty far on this one, and some of us have got this one, but others are having trouble. That's where I see us at the moment. How many had you correct on this one? Okay, most of us. Good. So, two things to point out here before I go through the rest of it. Point number one, make sure that when you put your du, there's also a ds to match with it over here. Same thing here. When we put du, we're going to put a dx over here to match with it, because otherwise we can't actually do the substitution that we want. We want everything in terms of u when we take the antiderivative. Point number two, I do have an s to the 1/3 here. I do have a ds here, but this 4/3 I don't have. Doesn't match. Let's move it to the other side. So this will become a 3/4 du. And I'll go ahead and skip to the fact that this 3/4 is going to come out in front of the integral. And in future problems, I will skip to that kind of part of the process here. We still have cosine. And hopefully you spotted both things here. You spotted both the fact that the s to the 4/3 minus 8 was inside of my cosine, and so instead of that, we're going to put u. And hopefully you also spotted the fact that its derivative, which was the s to the 1/3 thing, is somewhere else in the problem. So both of the clues for figuring out what to make u were sitting there. And so now instead of s to the 1/3 ds, we're going to put 3/4 du. So then antiderivative of cosine is still sine. And let's do that substitution back in. So instead of u, it was s to the 4/3 minus 8. Plus c. Thank you. If you were hoping for the gimmick where I'm standing at the board forever, I'm only doing that once. All right. How many feel confident they have u on this one? I did see one or two people have it when I went around and checked. Clue number 1. Clue number 1, the function is inside of another function. Natural log of x is currently getting taken to the 6th power. So it is inside of another function and being taken to the 6th power. Clue number 2, the derivative of natural log of x is sitting right there somewhere else in the problem. In other words, I could rewrite this as the integral of that. That's the exact same thing as this. And now it's super clear, hopefully, what we're going to make u and what we're going to make du. This means the same thing as this, just rewritten. Because the natural log of x to the 6th is on top, and then that'll leave a 1 on top of here, and the x on the bottom. So this one was trickier to see, but both clues are there. And if you're in doubt, you should go back to the more of a giveaway clue is the first clue where you have a function happening inside of another function. So even if you didn't see it, my hope was that after a little bit of time, you'd say, you know what? This is getting taken to the 6th power. So what if I made u natural log of x? What would du be? Oh, 1 over x? Fantastic. It is over x already. So now this is going to be super simple. Because the 1 over x dx is already matching. I don't even need to multiply by anything to make it match. It already matches. So instead of taking natural log of x to the 6th, I'm just taking u to the 6th. Instead of 1 over x dx, du. Much, much easier to work out the antiderivative of. And antiderivative will be 1/7 times u to the 7th, which equals, let's do our substitution back in. What was u? U is natural log of x plus c. Questions on that? All right. Before class tomorrow, let's see. Before class tomorrow, G and H, same thing. At least I want you to think about what we're going to make u in each of those two problems, in G and in H. So that's where I want you to go